Okay, so we've got this piece of rock, and when it's 100 kilometers above the moon, it's going 870. And now we want to know what is its speed when it's 50 kilometers above the surface, right? So my original, I'll call it R1, is 100 kilometers above the surface of the moon. So we got to figure out the distance, from the center. So I'm going to go 100 kilometers plus 1.737 times 10 to the 6th, and that is 1.837 times 10 to the 6th meters. So that is my original radius, right? And then when it's 50 kilometers above the surface, it's going to be, won't it just be, okay, we'll do it. 50 R2, right, is equal to 50 times 10 to the 3rd plus 1.737 times 10 to the 6th. Won't that be 1.787 times 10 to the 6th? Let's check that. I'm going to double check that. 50 E3 plus 1.737 E6. Yes, indeed, it's 1.787 times 10 to the 6th meters. Okay. So now, let's draw a picture of this, right? Here's the moon. Here we are, watching it all go on. Right, the rock is here. I'm going to exaggerate the height, right? So when it's 100 kilometers, it's going 870. So the question is, when it's halfway down, when it's at 50 kilometers, what's its velocity? That's our question. So I'm just going to say kinetic plus potential here equals kinetic plus potential there. Okay? I think we can deal with this. Okay, so I've got minus g times the mass of the moon, mass of the rock, right, over R1 plus 1/2 mv1 squared, right? This is v1, right? Is equal to minus g mass of the moon, mass of the rock over R2, which is this, right? Plus 1/2 m, and it's v2 that we're trying to find, right? Now notice that the mass of the rock cancels out. So we can just cancel that out there. And now I think we're ready to put numbers in. So minus g times 7.35 E22, that's times 10 to the 22nd over, and it's this high, right? So it's 1.837 E6 plus 1/2 minus g times and now this new one is 1.787 plus 1/2, and then we're solving for this velocity. I'll just call it v, I guess v2 squared, right? All right, so let's figure out everything in these parentheses here. And then what I'll do is I'll subtract that, and then we can do maths. Okay. Okay, so g times 7.35 over this plus 1/2 that. This is minus 2290276.184. And then this one is alpha F1 opposite of g times 7.35 E22 over 1.787 E6. So this guy is negative 274.3396.754 plus 1/2 v2 squared, right? So what I'm going to do is I'm going to go this guy minus a negative this guy. Okay, so the first guy, boom, minus the second guy. And luckily this number is positive, otherwise we'd have a hard time finding the square root of a negative number. So 453,120.57 equals 1/2 v2 squared. Okay, so we can do this. So times 2 raised to the 0.5. I'm getting that v2, the velocity at 50 kilometers elevation, is 951.966. So I guess 952 meters per second. All right.